Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. Thanks for coming to class today. Today we are going to consider a particular topic on geodetic surveying, and on that topic we are going to look at the relationship between the parameters we use to compute on the ellipsoid, like the flattening, the eccentricity, semi-major, semi-minor axis, and the rest of that. So we will be given some formula, and then we are going to show the relationship between those parameters. So the first thing we are going to look at is that they said if f is equal to a minus b all over a, e squared is equal to this, e prime squared this, m this, and then n this, we should show the following relationship. We are given 5 relationships, so they said we should show how they are related. So your A is your semi-major axis, B semi-minor axis, flattening, eccentricity, and the rest of that. Now let's continue. The first thing now is the A part, where they say we should show that what E squared is equal to 2f minus f squared. Now we've already been given what E squared is. They told us that E squared is equal to what? A squared minus b squared all over a squared. So I would just want us to recall our basic physics, where we have derived and fundamental formula, derived and fundamental units. You know your length is a fundamental unit, but your area is not a fundamental unit. Your area is a product of two fundamental units. So your area is what is derived. So I just want us to have that as a basic knowledge, because it's something like that we are going to do right now. So we are going to take one as a basic unit, and we are going to take other as a derived unit. Is that clear? It's alright. So now let's continue. So we are going to say that this f, as it was given to us here, is what? A minus b all over a. That was the f given to us. So now if we want to work from the right hand side to get to the left hand side, it's still very simple. How do we go about it? So f is equal to what? A minus b all over a. Is that not good? This then implies that 2f minus f squared will now be equal to what? 2 into a minus b all over a minus what? A minus b all over a squared. Because anywhere we see f now, we replace it with what? A minus b all over a. Substitution. Are we together, please? It's alright, thank you. Now the next thing, now we are going to open this bracket. So open this bracket, we have what? 2a, 2 times a, 2 times b. So we have what? 2a minus 2b all over a. Are we together? Minus, now what does this fraction in square mean? It means that the numerator is squared, the denominator is squared. So by the time we simplify the numerator squared, which is a minus b squared, we have what? A squared minus 2ab plus b squared, divided by the denominator squared, which is what? A squared. Are we together? You can just run this out yourself, and you find out that you come up with this: a squared minus 2ab plus b squared. Good. Now the next thing is for us to open this bracket, because there is actually a bracket here. So by the time we open the bracket, we have minus a squared plus 2ab, then minus b squared, because minus times plus will give you minus. Are we together? So we now have 2 fractions. So having 2 fractions, we are going to solve it like a fraction. And the first thing is that we have to find what? We have to know their LCM. So the LCM of these 2 fractions here is what? A squared. Please, are you following it up? Good, thank you. Now the LCM of these 2 fractions is what? Of these 2 fractions rather, is what? A squared. So a squared divided by a will give you a. Right? Good. Now this a multiplied by 2a minus 2b. So it will now be what? 2a squared, because a multiplied by 2a will give you 2a squared, minus a multiplied by 2b will give you what? 2ab. Right? Good, you got it. So now the next thing is what? A squared divided by a squared will give you 1. So 1 multiplied by the whole of this, you still have the same thing here, which is minus a squared plus 2ab minus what? Minus b squared. Hope you didn't miss any point. It's right. Now let's continue. So the next thing, now we are going to collect like terms. We have a squared, we have 2ab, and then we have b on its own. So we have 2a squared minus a squared minus 2ab plus ab minus 2a plus 2ab rather then what? Minus b squared. So what? 2a squared minus a squared automatically gives you what? 1a squared, which is the same thing as a squared. Good. Then minus 2ab plus 2ab gives you 0. Plus 1 minus 1 or minus 1 plus 1 gives you 0. Then we have our minus b squared here. So we have what? A squared minus b squared all over a squared. So recall from the basic, let's say, the fundamental formula given to us that what? E squared is equal to a squared minus b squared all over a squared. And we have also gotten a squared minus b squared all over a squared, which is the same thing as what? E squared. Therefore, we have proven that what? E squared is equal to 2f minus f squared. And it is also equal to what? A squared minus b squared all over a squared. Are we together? It's that simple. Thank you very much. Now let's get to the second part. The second part is also simple. The first thing we are going to do here is what? They said we should show that e prime squared, which is the second eccentricity squared, is equal to e squared over 1 minus e squared. So it's still the same way we are going to go about it. Recall that your e squared is equal to what? A squared minus b squared all over a squared. Is that not? This then implies that e prime squared will now be this your e squared, which we are now replacing with a squared minus b squared all over a squared, divided by 1 minus a squared minus b squared all over a squared. So wherever you see e squared now, we have replaced it with this fraction here. Good. So solving the denominator, we have something like this. So the denominator is equal to what? The denominator is 1 minus a squared minus b squared all over a squared. So we are going to solve it as a fraction. The LCM here is what? A squared. So since the LCM here is a squared divided by 1 will give you what? Will give you a squared. So a squared times 1 will give you the same a squared here. Then a squared divided by a squared will give you what? 1. 1 times everything here will give you a squared minus b squared. Right? So remember that there is also a bracket here. So by the time we open the bracket, we have what? A squared minus a squared. And then this minus multiplying this minus will give us plus. So by the time this a squared and this a squared will add and subtract itself, it will become 0, because it will now be what? A squared minus a squared, it will be 0. Then this minus multiplying this here will make it plus. So we have what? B squared divided by a squared. Therefore, the denominator simplified will give us what? B squared over a squared. Are we together? Good. So now solving the fraction, remember that it was a fraction of what? The fraction is what? E squared over 1 minus e squared. So now solving the fraction, we have, since we have changed our e squared to a squared minus b squared all over a squared. So solving the fraction, we have what? A squared minus b squared all over a squared divided by b over a. The b over a is this b over a we got here. Remember that this was the simplification of the denominator. Good. So by the time we want to solve it, we have to change this division to multiplication sign, and then we have a reciprocal here. So we have what? A squared minus b squared all over a squared times a squared over b squared. Are we together? The numerator comes up. Sorry, the denominator comes up. The numerator comes down. So by the time we multiply through, we have a squared times a squared will give you a raised to power 4. Then a squared times minus b squared will give you a squared b squared divided by what? A squared b squared, because that's what we have on our denominators here. So the two multiply each other, we have a squared b squared. So the next thing we are going to do is that we are going to split this. Remember that this can have this denominator, this can also have this denominator, common denominators, and they were brought together. So we can also split them. So for us to split them, we have what? A raised to power 4 divided by a squared b squared minus what? A raised to power 2b squared divided by a squared b squared. So we now see that these two are the same, therefore they can cancel out, leaving us with 1. So by the time we come here, we have a raised to power 4 here. Is that not? And then we have a raised to power 2 here. That means these two can cancel 2 of these. We'll be left with 2 here. Are we together? These are simple indices or maybe fraction indices in mathematics. So we have squared here, we have 4 here. So by the time this squared take 2 off here, we'll still be left with 2, and then this squared will go. So we have what? A raised to power 2 divided by b squared. The a here has been taken off, part of this, which is now leaving us with 2. Are we together? Minus 1, because after these 2 cancelled out, we are left with 1. Is that not? Good. So now this is another fraction. The fraction here is that b squared is our what? Is our LCM. So by the time we use b squared as our LCM, we say b squared divided by 1 will give you what? B squared divided by b squared rather will give you 1. 1 times a squared will give you a squared. Right? Good. Minus b squared divided by 1 will give you b squared. B squared times 1 will give you what? B squared. Is that not? So by the time you do something like that, you have what? A squared minus b squared all over what? B squared. And remember that a squared minus b squared all over b squared is, as given to us here, is equal to what? E prime squared. Therefore, it has been proven that what? Therefore, it has been proven that our e prime squared is equal to e squared over 1 minus e squared, which is equal to what? A squared minus b squared all over b squared. Are we together? Good. Please, you just have to take time to follow it up. These things are quite simple for us to understand. Now, let's look at the next part. See, they said 1 minus e squared in a bracket multiplied by 1 plus e prime squared equal to 1. So that means the product of these two should give us 1. So starting from 1 minus e squared, this implies that we have 1 minus a squared minus b squared all over a squared, because that's what e squared is. So by the time we solve this as a fraction, we have what? A squared minus b squared all over a squared. Are we together? So by the time we open the bracket, we have what? This minus multiplying this will give us minus. This minus multiplying this will give us plus. So we now see that this a squared will cancel out with this other a squared, because a squared minus a squared will give you 0 plus b squared all over a squared. Therefore, for this 1 minus e squared, we have what? B squared all over a squared. Are we together, please? It's alright. Also, the next part of it is that we have 1 plus e prime squared. The same process we are going to take. What's our e prime squared? Our e prime squared is equal to a squared minus b squared all over b squared. So we are going to still solve this as a fraction. So by the time we solve this as a fraction, we have what? B squared plus a squared minus b squared all over what? All over b squared. Are we together? Good. So now this is equal to, by the time we collect like terms, because we have b squared here, we have b squared here, so we have to collect like terms. So b squared minus b squared plus a squared divided by b squared. So what? B squared minus b squared will give us what? 0. So we now have what? A squared over b squared. Therefore, remember that these two were products. They were multiplying each other. So we now say, therefore, b squared over a squared multiplied by a squared over b squared is equal to 1. Because a will cancel a squared rather will cancel a squared, b squared will cancel b squared, and we'll be left with 1. This then implies that we have proven that 1 minus e squared into 1 plus e prime squared is equal to 1. Are we together? Hope you followed it up to this point. It's alright. Thank you. We are almost done. So now let's look at the fourth one. The fourth relationship we have here says that we should show that b is equal to a into 1 minus f. B is equal to what? A into 1 minus f. So what does that mean? We are going to start with 1 minus f. So f is equal to what? A minus b all over a. Therefore, 1 minus f will be what? 1 minus a minus b all over a. So we are going to solve it as a fraction as we've been doing. So by the time we get to this point, there is a bracket, so we have to open the bracket. So we have what? A minus a, then a, this minus will multiply this minus here, so it will give us plus here. So by the time this a minus a goes out, we have, by the time this a minus a, we perform the operation, we have 0. So we now have what? B over a. Therefore, this 1 minus f will give us what? B over a. So remember that it is multiplied by a. Also, a into 1 minus f will now be what? A multiplied by b over a, because that 1 minus f has been simplified to what? B over A. So by the time we now cross each other, A and A will go off, we'll be left with B. Therefore, B is equal to what? A into 1 minus f. Are we together? Please, these things are very simple. You just have to, any point you miss, just pause, rewind, get it, and then you proceed. So now, the last one on this particular video is what? M equal to 2n over 1 minus n squared. Are we together? So we are going to solve the numerator first. We already know what our n is. We've been given as a basic formula there that our n is equal to a minus b all over what? A plus b. Therefore, 2n will be what? 2a minus 2b all over a plus b. Established, right? Good. Now the next thing is we are now going to consider our denominator. And on our denominator we have n squared. So we are going to look at the n squared first. So we know what n is. So when we get n squared, it means that the whole of this squared, or you square the numerator separately, you square the denominator separately, as we've actually adopted here. Therefore, 1 plus n squared will be 1 plus the whole of this here, which is what? A minus b squared all over a plus b squared. Are we together? Please, I just want you to take your time, listen, I know you will get it. Thank you very much. Now, we are going to look at this as a fraction again, normally. The LCM here is what? A plus b squared. So a plus b squared divided by 1 will give you a plus b squared. So this multiplied by 1 will still give you what? A plus b squared, right? Good. So now a plus b squared divided by a plus b squared will give you 1. 1 times a minus b squared will give you what? A minus b squared. Therefore, we have simplified this. We have simplified what? This. And this is what? Our denominator here. Which means that if we are now going to join everything together, which was given to us as what? 2n over 1 minus n. The 2n has been gotten as what? We've simplified to get what? 2a minus 2b all over a plus b. And then 1 plus n squared, we've simplified it to be this. Therefore, by the time we join them together, we have something like this with this division. So for us to perform an operation, we have to change this division to multiplication. Changing this division to multiplication, there will be a reciprocal here. So the denominator goes up and then the numerator comes down. So we have what? 2a minus 2b all over a plus b multiplied by, this will now come up, a plus b squared divided by what? A plus b squared plus what? A minus b squared. Are we together? Now the next thing is that you see that we have a plus b here, we have a plus b here, and then we have 2 of this. That's why we have a square. So by the time this and this goes, this will go off and we'll be left with 1 of this. Are we together? Good. So when we are now left with 1 of this, it will now be what? 2a minus 2b. Since this has been cancelled out, there will not be anything here. So we have 1 as our denominator multiplied by 1 of this was cancelled out. Is that not? 1 of these cancelled out this, so we now have a plus b without a squared divided by a plus b squared plus what? A minus b squared. Are we together? Good. So the next thing now is for us to do what? Is for us to open the brackets here. Normal multiplication. So we have 2a multiplied by a will give us 2a squared. Is that not? 2a multiplied by b will give us 2ab. Minus 2b multiplied by a minus will give us minus 2ab. Then minus 2b multiplied by b will give us what? Minus 2b squared. Right? All over what? A plus b squared plus a minus b squared. I hope you're following it up, please. I hope you're following it up because it's very important and it's very simple. Thank you very much. So we see that we have minus 2a plus 2ab. Minus 2a plus 2ab minus 2ab, so they can go off. So we'll now be left with what? 2a squared minus 2b squared divided by our denominator, which we have not performed any operation on, which is what? A plus b squared plus what? A minus b squared. So by the time we simplify this, normal opening of expansion of bracket, we find out that we have a squared plus 2ab plus b squared. By the time we simplify this also, we have what? A squared minus 2ab plus b squared. Therefore, the addition of the both, which was actually what we have on our question, will be what? A squared plus 2ab plus b squared plus, that's why this plus is quite big. a squared minus 2ab plus b squared. So we now find out that this 2ab will go with this 2ab. Is that not? So we have 0. Then this b and this a squared plus this a squared will give us what? 2a squared. This b squared plus this b squared will give us what? 2b squared. Therefore, we now have something like what? Remember that this numerator has been simplified as what? 2a squared minus 2b squared. And we are trying to simplify this denominator. And the simplification of this denominator gave us what? 2a squared plus 2b squared. So we now have what? 2a squared minus 2b squared divided by what? 2a squared plus what? 2b squared. So by the time we factorize, 2 will come out for both the numerator and the denominator. So we have what? 2 into a squared minus b squared, and we have what? 2 into a squared plus b squared. So these 2 will go out, will cancel out each other. Then we are now left with what? A squared minus b squared all over what? A squared plus b squared plus b squared. Remember that this a squared minus b squared divided by a squared plus b squared is equal to m, as already stated earlier on the fundamental quantities given to us. Therefore, it has been proven that m is equal to 2n over 1 plus n squared, which is also equal to what? A squared minus b squared all over a squared plus what? Plus b squared. Are we together? It's alright. So yeah, so this is this is the much we have to discuss today on this particular video. Thanks for coming to class. I hope you've learned something new, and I hope we've actually provided solutions to this particular problem. So if you're coming to this channel for the first time and you've not subscribed, please subscribe to the channel, and then make sure that you leave a comment there. You also like the video, help us share the video with your friends so that they can also come and benefit from this wonderful solution you've just gotten. So thanks for coming to class. Until I see you again on the next video, make sure you stay safe and then you take your studies seriously. Be good.